So everything we've been doing this far has been dealing with equations, right? We've been solving equations, and the whole idea has been for us to get a variable all by itself to know what it's equal to, right? And what we're doing today is going to work really similarly. But today we're starting to talk about inequalities instead of equalities. And a lot of you probably remember inequalities a bit, right? Inequalities, gotta say it to spell it. In terms of these signs, you've probably seen all of those before. We've got this one is less than. If I have X on the small side and A on the big side, I'm saying that X is less than A, right? The small side is the side that's less. So if the small side was pointing at the A, it would be A is less than X. In this case, I could say this two ways, right? I could say that X is less than A, but I could also say that A is greater than X. Both those statements are true. They mean the same exact thing, right? If I look at this one where it's got the line under it, we're saying that X is less than or equal to A, right? Now, I could flip that around and say that A is greater than or equal to X. It means the same thing, right? Last day of the triad is Friday, Mariah. So if I have X here and A here, I'm saying that X is greater than or equal to A. And here X would just be greater than A. Now, I've heard a lot of people go, okay, the arrow goes in the direction of the sign when you're graphing things like this. Don't pay attention to any of that. Know what you're solving for. If you are solving for X, everything that you're graphing is about X. So if I were graphing X is less than A, whatever A is on this number line, I can call this A, right? Doesn't matter what it is, it's some number. If we're graphing that, we're saying that X is less than A, right? It is not equal to A, so we would use an open dot to represent it, or we would use a parentheses to represent it because it is not equal. So we would have an open dot at A because we're not including it, and it would go in the direction of everything that is less than A. When we've been dealing with equations, we have one set answer, right? Normally we have one, maybe two answers in the terms of absolute values. But when we're dealing with inequalities, we have sets of answers, right? And in this case, the entire set of answers would be from A all the way to negative infinity, right? And everything that falls in that category is a true solution to the statement. If we're looking at X is less than or equal to A, I'm still going to have my A, and we're going to represent it this time with a closed dot because we're actually including A in the solution set. We're not just starting at A. And we could use a bracket to represent it. So I could use, in this case, we could use the open, or we could use a parentheses. Here, we're going to use closed dot and an arrow, or we could use a bracket to represent it. Right? The bracket means we're including a parentheses means we're not. A closed dot means we're including a, an open dot means we're not. And that's going to be the case in terms of greater than as well, right? It's just the arrow is going to go in the other direction. In your homework today, you're not going to have to graph them, but I'm going to graph every example because in your homework later this week, you are going to have to graph them. So I just want you to see the graphs a little bit more. Today, you're just going to have to come up with the solutions, but later this week, you'll have to graph all of those solutions. So I want to make sure that you know how to do it. The other thing you're going to have to do later this week that you're not doing now is you're going to have to be able to write this in interval notation. This goes to infinity, right? So if I was writing this, I would write this as parentheses negative infinity because it starts from negative infinity and then it stops at a, but does not include a, so it would be in parentheses. In this case, we're starting at negative infinity, which infinity always gets a parentheses, but we are including a, so it would be a bracket. Does that make some sense there? So we just basically, that's how we determine what the set of all of these is. So if I am looking at this in terms of, say, x is less than or equal to 8, and I wanted to graph that, I would have a number line, right? And the only number that matters on that number line for me is 8, but you would have all sorts of numbers around it, but I would only care what's happening at 8. And in this case, what's happening at 8 is we're saying that x is greater than or equal to 8. That means we are including 8. So we would have a closed dot, and it would be also everything bigger than 8. Follow? One more rule before we start getting into the more complex problems is when you're solving these, when you're trying to isolate those variables, because we're not just going to get what x is greater than or equal to, we're going to get a crazy, I want to say equation, but it's an inequation, right? That you're going to have to isolate that x. You're going to have to do all of the manipulations just like we were doing when we were solving equations, right? Only now we're doing it for inequalities. But there's one different rule when we're dealing with inequalities, and that is the biggest rule. So we'll make a big star right here. If you multiply or divide by a negative, you must, does anybody know where I'm going with this? Switch the direction of the inequality. You guys will mess this up because you all do all the time. I even do on occasion. So if you are solving an inequality and you're trying to get that variable by itself and you multiply or divide, and only when you multiply or divide by a negative number, you have to flip the direction of your inequality. So your less than becomes a greater than, or your greater than becomes a less than. And you'll get plenty of examples with that, but I just wanted to make sure that you clearly saw it, that we put a big star next to it so that you know it's important. And on that note, we're just going to do a few examples. Our first example that we are going to do is number 1, because it seems the appropriate number for the first one. If I have 5x plus 1 is greater than 7x minus 17, right? My first thing I'm going to have to do is get the x's all by themselves, right? So I want all the x's on one side. And I'm going to start by moving them to one side or the other. I always like them on the left. I don't know why. Maybe because it reads better that way in the end. So I always will move my variable that I'm trying to solve for to the left. And I'm going to do that by subtracting 7x from each side of the equation, or the inequation, the expression. I don't know what to say. It's not an equation. And here I'm going to get negative 2x plus 1 is greater than negative 17. I didn't switch anything because I subtracted an x. I didn't multiply or divide by it. Is that a plus? Yes, it is. It's negative 2x plus 1 is greater than negative 17. Now I'm going to start moving everything that's on my variable off of my variable, right? So I am going to start with what's being added or subtracted to it. And in this case, we have 1 being added to it. So I am going to subtract 1 from both sides. And I will be left with negative 2x is greater than negative 18. The only thing left I have going on there is that I have this negative 2 that's still attached to the x. That negative 2 is being multiplied, right? If it's right up against the x, that means we're dealing with multiplication. So to get rid of it, we have to do the opposite of multiplication, which is divide by negative 2. And if you remember that rule that we made up there, when I divide by a negative, we're going to have to switch the direction of our inequality. So right now we're going to be left with x, and I'm going to take this inequality, I'm going to turn it the other way, is now less than negative 18 divided by negative 2 becomes a positive, and we have x is less than or equal to 9. This will be how you enter it in Delta Math, right? If you had to graph it, which you won't on your homework, but next week you will, so we're going to show it. We're going to put 9 here, right? We're saying that x is less than 9, right? So we're going to have an open circle, and it's going to be everything less than 9. And if we had to write that in interval notation, it's starting at negative infinity, and it's going to 9, but not including it. Did you kind of feel that? So that was a fairly simple one, right? We had to move our x's to one side. We had to move our numbers to the other side. Sometimes we're going to have to do a little work before we can get there. So if I have, I should call it 2, number 2, example 2. 12p plus 52 is greater than negative 2 times 4 minus 2p. So if I have parentheses there, I can divide out that negative 2 first, but because we already have a plan of action when we're dealing with equations and that we're supposed to distribute first, we're going to go ahead and distribute that negative 2 first instead of dividing it out first. It doesn't matter. It's just a lot of times if I tell you to divide it out first, you forget to do it to both pieces of the other side. So I'm going to go ahead and rewrite this as 12p plus 52 is greater than, and I'm going to distribute this -2. So I have -2 times 4, which is -4. And here's the part that everybody forgets, is that I also have to multiply that -2 on this side, which is going to be -2 times -2, which is positive 4p. Right. And now we can solve it just like we did the other side. We can move our p, our variable, over to one side. And I have plus 4p, so I'm just going to subtract 4p from both sides. And with that, I'm going to have 8p plus 52 is greater than -4. And now we just have to move everything off of the variable that we have stuck to it. We don't flip because we did not multiply or divide by -4. We just subtracted.
But didn't we do -2?
Oh, it's only that, you know what? That's a really good question, because I should have been more clear with that. We're not moving it to the other side. We're not using it to move it. We're just combining like terms in that scenario. So if I were to divide out that -2 first, I would have had to flip it. But because we didn't divide out the -2 first, we multiplied it through that one side. If you're working on one side, you don't have to flip it. But if you're working on both sides, you have to flip it. So thank you, because that clarification did need to be made. So now we are going to subtract 52. And I'm going to wind up with 8p is greater than -56. And the only thing we have left is that p is being multiplied times 8. So I'm going to divide by 8 and divide by 8. And I'm not going to get a pretty number. I'm going to have p is greater than -56 over 8. Am I allowed to leave it like that? Heck no, right? Everything here is divisible by 2. So I'm going to go ahead and divide that 2. -56 divided by 2 is I messed up. Did you see where I messed up? Nobody even caught me. What's -2 times 4? Yeah. You see where I messed up? This is supposed to be -8, which would make this -8, which would make this -60 over 8. Did you see how I messed that up? Which makes this a little easier to deal with, because this becomes -30 over 4, which is also -15 over 2. So we have p is greater than -15 over 2. I like that when you start to do stuff really complex, and then you notice where you mess up is I multiplied -2 times 4, and for some reason I got -4. Yeah, but it took me a while to get there, Lacey. The good news is I have more sample problems for you. I'm going to do some where the solutions are a little bit different, so you can see what that looks like. If I wanted to graph this, before I move on, if I wanted to graph p is greater than -15 over 2, and I want to look at this graph, I'm going to have my number line, right? -15 over 2 falls between -7 and -8. You don't have to be super specific about that. I mean, technically it's -7.5. So it's going to be a point here, right? It's going to be an open point here between the two, right? And it's going to be everything bigger than it. So if you have a fraction, remember, you don't have to be perfect, but you kind of have to know what numbers those fractions lie between, right? So if I had -2/3, that's going to be between 0 and 1, and or 0 and -1, and you're going to want to put your point in between there. If I look at it in terms of interval notation, I'm going to have my point at -15/2, and it's going to go all the way to positive infinity. So let's look at it when the solutions are weird. Right? If I have 3 times 8x minus 9 greater than 4 times 6x plus 1. First thing we're going to do is we're going to distribute both sides, right? We have parentheses on both sides, so we're going to distribute, and we're not going to mess up the math this time. 3 times 8 is 24x. 3 times -9 is -27. Greater than 4 times 6x is 24x, and 4 times 1 is 4, right? So I'm going to move this 24x over. I'm going to subtract 24x from both sides. When I do that, this disappears, and I'm left with -27 is greater than, this disappears, 4. So I have a statement now, and my statement doesn't have any variables in it, right? Our x's disappeared, right? They subtracted out. I have a statement, though, that says that -27 is greater than 4. Is that a true statement? Is -27 bigger than 4? If something like this happens and your x's disappear, right? They subtract out because they were the same on both sides, and your statement is not true, you have no solution. This is your answer, no solution. Because this is not a true statement. It can't work. No matter what value that we put in for x, it will never be true. Does that make sense? Well, I'm going to get to that one right now, Kevin. I'm going to do one where it is true. So that is an excellent question. So if I have 11x minus 4 less than or equal to 6x minus the quantity 3 minus 5x, and we go to solve that. We're going to start with our distribution, and you might be thinking there is no distribution because there's no number in front of it, but this negative represents -1, and we do have to do that distribution. So I'm going to rewrite this as 11x minus 4 less than or equal to 6x. I'm going to distribute this through here and get -3. And then I'm going to distribute it through here and get plus 5x. Here I have x's, 2 separate x's on the same side of the inequality. So I'm just going to go ahead and combine those. And I'm going to have 11x minus 4 less than or equal to 6x plus 5x is 11x minus 3. So you can already see what's happening here because we have 11x on both sides, right? So I'm going to go ahead and I'm going to subtract my 11x from this side and from this side. And I'm going to be left with negative 4 is less than or equal to negative 3. This is a true statement, right? Negative 4 is less than negative 3. If the statement is true, your solution is all real numbers. What that means is that anything that we put in for x will make this statement true, right? Because if I put it in for x on one side, I have to put it in for x on the other side. Each side will be being multiplied by the same exact thing. So it's always going to stay true that the one side is less than the other side. So all real numbers would be your solution. If I was graphing it, which I am right now. So here's my graph. We could pretend there's numbers on here. To graph that solution, it would just be kind of like that, right on top of it, right? There's no actual points. Every number on the number line is a valid solution. If I was writing it in interval notation, it would be negative infinity all the way to infinity. Um, 28, we get out of 937. That is all I have for you in terms of the lesson portion of this. I'm going to go into Delta Math, though, and show you the assignment and how to enter the things, but I'm going to stop the video now because there's no reason to record that.